All right, so I'm going to go through this video really quickly. I was supposed to do it during last period today, but then I had to go get my visa, so I just didn't get home till now. So I'm going to try and make this really quickly. So if you need any help, just make sure you are reaching out, or just make sure you're studying. All right, so 135 people have come to AIC Carnival so far. 35 people bought a salad from aquaponics class. Find the probability that the next person who goes to the carnival will buy a salad from aquaponics. So remember, it's what we want or what we're looking for. So that's how many people or if they'll buy a salad next. So 35 people so far have purchased a salad. And it's over the total, which is 135 people have gone to this. So now remember, we can use statistics and probability to then predict what the next person may do. So when we divide this, that is 0.259. So we can then say that there is the probability that they will buy a salad is equal to 0.259 or 25.9%. All right, so we can use this to say that the next person coming in, if nothing changes and everything is still, if nothing changes, we can just say that based on the people that have been buying a salad, that there's roughly a 26% chance that they will buy one now. All right, this next one says Sarah decided to record the number of goals she scored in each of her soccer games this season. I don't know why it says season. It should be games this season. And made a table. Use this information to find the following probabilities: that she will score at least 2 goals, and is this likely to occur? Well, remember, it's what we want over the total. So first we need to figure out what the total is. The frequency tells us how often she scored each goal. So when we say 0 goals and the frequency is 4, that means 4 different games that she played this season, she didn't score a goal. So to find the total number of games she played, we would add up all the frequency. 4 plus 6 is 10. Plus 3 plus 2 plus 1 plus 1 is 17. So I know that this is going to be something over 17. So now we need to know, what does it mean when we say at least 2 goals? Well, at least 2 means it could be 2 or it can be more than 2. So it means any of these games where she scored 2, 3, 4, or 5 goals. So we would add these numbers up. So 3 plus 2 plus 1 plus 1 is 7. And 7 divided by 17 is equal to 0.412. So we will say the probability, remember this is how you have to write it, at least 2 goals is equal to, I'm going to write this as a percentage this time because remember, you can do it either way. It's 41.2%. And is this likely to occur? I would say that it is somewhat unlikely because it is less than 50%. So although it's close to 50%, which then means it's equally likely and equally unlikely, but since it's lower than less than 50%, it's still somewhat unlikely. But it's not as unlikely as if it were like 5% or something like that. All right, let's move on to the next question. All right, this one says, Ali decided to record the number of phone calls he receives each day and create a dot plot. Use the following information to find the probability that tomorrow Ali will receive the following number of phone calls. That he will receive at least 2 phone calls, but no more than 5. So remember, it's the exact same thing that we're just doing. So we need to find out the total first before we can go ahead and figure out the probability of anything. So to find the total, that is all of these dots here. So here I have 4, here I have 3, here I have 6, 4, 1, 2, 1. So that means in total, he kept track of the number of phone calls that he received each day. 4 plus 3 is 7, plus 6 is 13, plus 4 is 17, plus 1 is 18, plus 2 is 20, so 21 days. So there are 21 days. That's what each dot represents. At the end of the day, he wrote down how many phone calls he received. So there's 21 days that he kept track. So now when we say at least 2, but no more than 5, that means we're going from 2 to 5 inclusive. So 2 to 5 inclusive. So we're adding up only these numbers here. Let me use a different color. We're adding up only these numbers here, 6 to 2. So 6 plus 4 is 10 plus 1 plus 2. So that will then give me 13. So 13 divided by 21 is equal to 0.619. So I will then say the probability of at least 2, but no more than 5 is equal to 0.619. All right, this one says, Ismail decided to keep track of all the shots he took on goal and practice day. If he took 72 shots and made 33 of them, determine the probability of the next shot going in. So remember, we're going to do what we want over the total. So our total here is he took a total of 72 shots. We know it's going to be over 72. And since we want to know what the odds of his next shot going in are, and this says this is 33 of them made, that means we will use this number and we will put it 33 over 72. And then we just divide that, and that tells us that 0.458. So the probability of going in is equal to 45.8%. So that means that on average, when he shoots the ball, he's making it 45.8% of the time. So we could expect the next one that it would be a 45% chance as well of it going in. All right, because we can use his statistics to predict what he will do next. All right, list all the possible outcomes for the gender of the children and in order. That's the key thing here, in order. So that means once we say in order, BGG does not equal GGB, even though they're the same letters and it's two girls and one boy, because here our boy is the oldest and here he is the youngest. So in order matters. All right, I'm going to do this one in a 2D diagram. Remember, you can do it any way you want. So first, I'm going to put boy and girl, and I'll put that one in black, and I'll put this over here, boy and girl, in red, just so that way you can see the difference in which one I'm writing first. Because remember, you just got to stay consistent if you're going to use a Punnett square or the diagram. So I'm going to put the black letters first, so B, B, and G, G, and I will put the red letter second, so there's that B, and here is this G. All right, so remember, once we get this, we then take all of our answers, and that's going to help us generate our new Punnett square. So now I'm going to create this, but remember, whatever I put first, I need to stay consistent. So I'm going to put my answers at the top. So BB, GB, BG, and GG. And then here, it's our next options. It's going to be boy and girl again. And then same thing, I'm just going to go ahead and just stay consistent. So since I did the top first last time, I'm going to do the top first again this time. So here, it'll be BB. All right, I'm just going to pause this and fill this in. All right, so I put the top first. Since I did the top first here, the top had to go first. So you see that the black letters went first every single time. And then I put the green, B and G, in at the end. All right, so the reason why I think this one might be beneficial for some people is because it gives you all the lists exactly. So we would just go ahead, once we finish filling in this Punnett square, we just go ahead and just write everything out, and that is our list. All right, but remember, I don't care how you get to this answer, this list that I'm writing now. All I care about is that you just that you get this answer. You can just straight up list it right away. You can use the 2D diagram like we did here, or you can use a tree. It is your call. All right, here, a 52 card pack is well shuffled, and one card is dealt from the top of the pack. Find a probability that the card is a red queen. All right, so first, we have 52 cards. So I know for A, it's going to be something over 52. All right, then I got to figure out how many red queens I have. So we have one queen of each suit, and diamond and hearts are red. So that means I have two red queens. And 2 divided by 52 is equal to 0.38. So the probability of a red queen is equal to 0.0. So it's 0.038. All right, the next one for B, it says a red card or a 5. But remember, with a 5, we have a heart, we have a diamond, we have a spade, and then we have a club. Then we have a club. These two are red. So when we say a red card, we know we have two colors. So we have 26 red cards, and that is including the 5 of diamonds and 5 of hearts. So when we say or a 5, we won't include them because we've already counted them in this 26. So we are going to include any other 5 that is not a red, which is the 5 of spades and the 5 of clubs. So 26 plus 2 is 28. So that's how many total cards we can pick that will give us and will satisfy what we want, a red or a 5. There's still 52 total cards, so 28 divided by 52 is going to be equal to 0.538. So then the probability of a red or 5 is equal to 53.8%. Find a probability of rolling a die and getting the following outcomes. So when you see rolling a die, it doesn't say we're doing it more than once, so it means we're just rolling it one time. and it says an even number. So on a die, we have 1, 2, 3, 4, 5, and 6. Well, even numbers are 6, 4, and 2. So we have 3 possibilities, and there's 6 total numbers. So the probability of even is equal to 0.5 or 50%. For B, a 3 or 6, well, here we have 2 choices, 3 or 6. Now, the main thing here is this word or, right? Remember, or means it could be this or the other. As long as if it's one of them, then it's satisfied. So here we have 2 over 6 because we have 2 possible outcomes over 6 total. And that's going to be the probability of a 3 or 6 is then equal to 0.333. Now, the one thing you have to be careful for, if I say 3 and 6, well, it's impossible to get a 3 and 6 when rolling a die. So that will then give us 0 as our probability. So make sure you're understanding the words that we have and the way that I'm phrasing things. All right, the next one is find the probability of rolling a pair of dice and getting the following outcomes. So remember, when we roll a pair of dice, that means we're rolling 2 die. And here, each one has a possibility of 6 outcomes. So to find the total outcomes, we will just put it, we multiply them together. So that means we have a total of 36 possible outcomes. Well, to get a sum of 5, I can have 2 die, a red one and a black one, and I could roll a 1 and a 4. I can roll a 4 and a 1. I can roll a 3 and a 2, or I can roll a 2 and a 3. There's no other possible ways of me getting a sum of 5. So then from here, I count them up. I have 4 total ways of getting a sum of 5. So 4 divided by 36 is equal to 0.111. So then the probability of a sum of 5 is equal to 0.111. All right, for the next one, it says rolling a 3 and a 6. So that's key, and a 6. That means they have to happen at the same time. So it could be a 3 and 6, or here, let me erase this so you can see I'm talking about the 2 different die. I can have one die roll a 3 and my next die roll a 6, or that first die could have rolled the 6, the blue one could have rolled the 6, and then the green one could have rolled the 3. That's 2 different outcomes. So that means here we have a total of 2 over 36 outcomes. 2 divided by 36 is equal to 0.056. So then we would say the probability of a 3 and a 6 is equal to 5.6%. Remember, I don't care if you write it as percentage or as decimal. All right, so now for this one says the odds of Muhammad making a foul shot in basketball is 3 out of 5. The odds of Mustafa making a foul shot is 5 out of 7. Find the probability that both will miss their next foul shot. So be careful when you're reading this on the test. Make sure that you're understanding the odds I'm giving you, because I could say the odds of Muhammad missing a foul shot is 3 out of 5, and then that means if I want to talk about them both missing, you don't need to take its complement. So make sure you're following what I write down. Don't just rush through the problems. So here we're going to talk about Muhammad, and we're going to say missing. And here we're going to say Mustafa, missing. All right, so now if I look, it tells me Muhammad is making a foul shot, 3 out of 5. So if I want to find the odds of him missing, because that's what I need, because it says that they will miss their next foul shot, I need to take the complement of 3 out of 5. And the complement of 3 out of 5 is going to be 2 out of 5. Because remember, we do 1 minus the probability. All right, then if I want to find the probability of Mustafa missing, I look and say, all right, well, here they're telling me Mustafa makes his foul shots every 5 out of 7. So that means he's missing it every 2 out of 7. When I have multiple events and I want to talk about their probability together, we need to combine them. So we multiply them. This will then give me 4 over 35. And 4 over 35 is equal to 0.114. All right, so then the probability of both missing is equal to 0.114, or 11.4%. All right, for this one, it says we have a cooler contains 13 bottles of sports drinks, 5 lemon lime flavored, 3 orange flavored, and 5 fruit punch flavored. You randomly grab a bottle for your coach, a bottle for your friend, and a bottle for yourself. Find the probability of you randomly picking your coach an orange, your friend an orange, and yourself a fruit punch in that order. All right, so here we have 3 different events. So I'm going to draw these lines. Remember, you don't have to draw these lines. I just draw them because I think it allows you to then put what the probability of each of them are, and you can look at them individually. So here it's going to be picking your coach, your coach an orange, your friend an orange, and yourself, so me, a fruit punch. So before I go ahead and do anything, I need to figure out how many total drinks do I have in this cooler. So I have 5 lemon lime, 3 orange, and 5 fruit punch. So I have a total of 13. Right? So that means when I go to pick this first one, this orange, I have 13 drinks I could possibly pick as I'm pulling them out. And the first one I want is an orange. Well, I have 3 oranges in there. So that means I have a 3 out of 13 chance of picking an orange. Now, after I pick the orange and I give it to my coach, I don't have 13 anymore. I have 12 drinks in there. So that means this next one, I will have 12 total drinks in my cooler because I gave one to my coach. And since I gave an orange to my coach, I no longer have 3 in there. I have 2. So that means I have 2 out of 12 because he already received one of the 3 oranges here. And the same thing, after I pick this drink, which is an orange for my coach, I no longer have a 12, but I have 11. So that means when I go to pick my drink, I have 11, and I want a fruit punch. Well, there's 5 total fruit punch, so we will just go ahead and multiply these. So 13 times 12 times 11 is going to give me 1,716. And then 3 times 2 times 5 is going to give me 30. And 30 divided by 1,716 is equal to 0.017. So then the probability of getting, I'm just going to put the abbreviation, orange, fruit punch is equal to 1.7%. All right, you don't have to do this step. You don't have to show me this. If you have your calculator and you type it in, you can just go ahead and go straight to the decimal. Real quick about this one. When it doesn't say explicitly that it is without replacement, but if I'm picking a drink from my coach and he's going to take it and drink it, it's impossible for me to put that drink back in. So even though I didn't explicitly tell you without replacement, you should be able to identify that it's implied because this person is getting that drink. All right, this one said we have a bag containing 4 marbles, 4 red marbles, 5 blue marbles, and 5 yellow marbles. So let's just figure out our total right now. We have 4 red, 5 blue, and 5 yellow. So that means we have 14 total. You randomly pick 3 marbles without replacement. So that's telling me each one I'm not putting back in. So I have 3 marbles I'm picking. The first one I have 14. We want the probability that the first marble is red. So I want a red marble. And then the second is blue. And then the third is yellow. So when I go to pick, I have 14 total in this first one, and I have 4 red marbles. So I have a 4 out of 14 chance of picking a red marble. After I pick my red marble, I don't have 14 marbles in there anymore. I have 13. So I'm out of 13 now. In blue, I have 5 blue marbles, so it'll be 5 out of 13. And then once again, after I pick that marble, I don't have 13 anymore. I have 12. And then it says that when a yellow marble, well, I have 5 yellow marbles, so I will get 5 out of 12. When I have multiple events, I multiply them together to get my single probability. So 14 times 13 times 12 is equal to 2,184. And 4 times 5 is equal to 100. And 100 divided by 2,184 is equal to 0.046. So then the probability of a red, blue, yellow marble is equal to 4.6%. Right? Remember, because it's not replacement, the number of marbles that we have in this bag are going to get lower and lower. And then since we're changing colors each time, we don't have to worry about, oh, well, we picked a red marble, so there's one less red. Because each time we're looking for a different color. You roll a fair die and flip a coin. Find a probability of getting a tails and a number less than 3. So real quick, you can just draw this, a tails and heads, and then we have all the possibilities of getting a 1, 2, 3, 4, 5, and 6. So we can look at all of these possibilities of a tail 1, a tail 2, tail 3, tail 4, tail 5, and tail 6. Then we have a H1, H2, H3, H4, H5, and H6. So I can count up all these possible outcomes, and I have 12. I have 12 possible outcomes. And then it says, and a number less than 3. Well, all of these numbers are not less than 3. 3 is equal to 3. All these numbers are not less than it, and all of these do not include a tails. So then the only ones that could possibly give me that could satisfy what I'm looking for is this tail 1 and tail 2. So there's only 2 times that it will satisfy it. So this would then equal to 0.167. So the probability of getting a tails n less than 3 is equal to 0.167. Right, so this one, you could have listed it out like I did here and created that table, or you could have just thought about this one logically. You know that you have flipping a coin, there's 2 options, rolling a die, there's 6. So you know you have 12 total options. And because we only are focusing on when it's a tails, we don't worry about any of the heads. So then when we're saying less than 3, well, there's only 2 times we can get a tails and less than 3. So you could have just did this one logically as well. All right, so for this one here, it says Janet has a 75% chance of passing her test, while Chris has a 65% chance of passing his test. So find a probability of the following. Right now, when you're reading this, make sure that you are reading this properly. Right? Because I might say Janet has a 75% chance of failing a test, while Chris has a 65% chance of passing. Make sure you're understanding what I give you. Right? So don't just start jumping to conclusions because we did this example that they both are passing. Right? Make sure you're actually reading it. So remember, for A, first identify how many events we have. Well, we're talking about they're both passing their test. So we have 2 events because they're both taking a test. So we want Janet to pass and we want Chris to pass. Well, I told you Janet passes 75% of the time. So here, 75%, we know we can rewrite as 0.75. And 65%, we know we can rewrite as 0.65 because that's the percentage of Chris passing. So 0.75 times 0.65, we multiply them together, so this is equal to 0.488. So then the probability of both passing is equal to 48.8%. Right? Now for B, it's a little bit different. It says they both fail. So that means Janet is failing and Chris is failing. Well, if Janet passes 75% of the time, when she takes the test, she's either going to pass or fail. Even if you get a 60, you still pass. So it's either you pass or you fail. So that means if she is passing 75% of the time, she is going to fail 25% of the time, or 0.25. And if Chris is passing 65% of the time, he's going to fail 35% of the time, or 0.35. We multiply them 2 together to get our answer, and this is equal to 0.088. So the probability of both failing is equal to 8.8%. All right, and then the last one, Janet passes, but Chris fails. So here, I know that I'm going to do Janet passing and Chris fail. Well, they told me that Janet passes 65% of the time, so this is 0.65. And we know Chris fails 35% of the time because we just did that problem. Or if he passes Janet passes 75% of the time, not 65. And if Chris passes 65% of the time, we know he fails 35% of the time. So the odds of Janet passing and Chris failing, we multiply them 2 together, and that is going to be equal to 0.263. So the probability of Janet passing and Chris failing is equal to 0.263. All right, there are 17 tickets, numbers 1 to 17. You select 2 tickets at random. Find the probability that you select a prime number and then not a prime number. So first, let's just write out all the numbers. 1, 2 to 17. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. All right, now we're talking about prime numbers. So let's go ahead and highlight all of our prime numbers. 2 is prime. 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime, and 17 is prime. So if we're selecting 2 numbers, because it says we're finding a probability that you select a prime number, then not a prime number, that means we're doing 2 events. So it is going to be prime and not prime. So when we go to select this, we have 17 numbers or 17 tickets. So we have 17 possibilities when we select a prime. Well, how many prime numbers do we have? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 prime numbers. So now, after we select a number, we have 7 prime numbers, so 7 prime, And then if we have 7 prime, that means we have 10 numbers that are not prime because we have 17 total. Or we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means after we select a prime number, let's just say we selected 2, we no longer have 17 total, but we have 16 total tickets now. And now we still have 10 numbers that are not prime because that first number or ticket we selected was prime. It was 2. So we have 10 over 16. We multiply these two together. So this will then give me 70 divided by 272. And 70 divided by 272 is equal to 0.257. So then we would say the probability of getting prime, then not prime, is equal to 25.7%. Right, last question. That's it for this video. Right, now the last one is we have a lottery has 150 tickets, which are placed in the barrel. 3 tickets are drawn at random. So that means we have 3 prizes. All right, we'll have first, second, and third. Christina has 10 tickets, so Christina has 10. And that means others that are not Christina must have 140 because there's a total of 150. So determine the probability of Christina winning first and second prize. So for A, we know there's 3 events. There's first, second, and third. Right? And we want Christina to win these 2, and then we want the others to win this third one. So since we're doing a lottery, if they win first place, they can't win second place. So it's without replacement. Even though it doesn't explicitly say it, it's without replacement. Right? So now, if Christina's going to win first place, she has 10 tickets that she can win, and there's a total of 150. So it's 10 out of 150. If we take one of Christina's tickets, she no longer has 10. She has 9 left when we're doing second place. There's no longer 150. There's 149 now. Right? Because she won first prize. So she went from 10 tickets to 9. And then there's 150. So after you take a ticket out, there's now 149. So now for third place, we want the others to win. Well, we have a total of 140 tickets for everyone else. So 140. Now we took out 1 ticket, so that made us 149. We take out 2 tickets. That means here we have 148 left over. So then to solve for this one, we just go ahead and multiply across. And this will then give me 3,307,800. Now you guys can reduce this. I'm just multiplying these on my iPhone right now. So that's why I'm not reducing these first, which is then going to give me this larger number. So then we multiply the top, it's 12,600, and we divide it by 3,307,800, and that is going to give me 0.004. So the probability of winning first and second is equal to 0.4%. Right, now the second one, we don't want her to win a prize. So for probability, it's the others on all of these. So others, others, and others. Well, we know there's 140 tickets that everyone else has out of the 150. Well, if we select a ticket that's not Christina's, then that means we selected one of the other tickets, so they're at 139, and the total is now 149. If we select another ticket that's not Christina's, same thing. Their total goes down to 138, and that means there's a total of 148. We will go ahead and multiply these. So I know it's out of 307,800. And then 140 times 139 times 138 is equal to 2,685,480. And I'll divide it by 3,307,800. And that is going to give me 0.812. So that means the odds, so the probability of not winning is equal to 0.812. All right, that is it for this video. I know I went through this quickly, but just make sure you guys are going through these problems. Make sure you know how to do these on your own.